In this video, we're going to look at adjusting and customizing our spot elevations to control the height of the building. So to do that, we need to go to a vertical viewing position. So I'm on my list of views here, I've got elevations. So I'll just pick one of the elevations. We were there when we initially moved our spot elevations up so that the main subfloor was 100 feet. Now we're going to just adjust these to suit our particular building. And if you look at the prelim of this preliminary layout of this house, it had 8-foot walls, not 9 foot. So I'm going to adjust that. Top of the main wall is going to be an 8-foot one wall, so it would be 108 feet 1 inch. So that drops down. The subfloor to the second floor would be made up of our floor truss, which the depth floor truss or I-joist is going to be determined in our structural framing analysis. So for this project, we're going to assume a 20-inch I-joist or floor truss. So 20-inch high plus a 3/4 inch subfloor. So that's 20 3/4 on top of 108-foot 1 inch spot elevation. So 20 3/4 is 1 foot 8 3/4. So that spot elevation would now be 109 feet 9 3/4 inches. Okay, so 109 feet. And then once you hit the foot symbol, you can just start with your inches. 9 space 3/4, and we don't have to put the inch symbol, and that will adjust. From that, we're going to assume also an 8-foot one wall on the second floor. Now these spot elevations are all figured out ahead of time on a piece of paper in our preliminary stage. So I've got them all written down in front of me here. So that's how you would approach it. You're not going to just think of it now as you're sitting here. So 109 9 3/4 plus 8-foot 1 is 117 feet 10 3/4. Oops. Sorry. Hit the wrong button. Oops. It's too close to the there. 117 feet 10 space 3/4. Okay, so that sets our above grade spots. Now for below grade, again, for the main floor we have to subtract 20 3/4 inches. We're going to stay to the top of the foundation. I don't like it saying foundation wall because I want this to go to the top of my foundation, including the sill plate. Okay, assuming we're using a sill plate, so I'm just going to call it top of foundation, and it is a spot elevation of 98 feet 3 1/4. So it's again 20-inch truss with 3/4 inch subfloor off of the main floor. So 98 feet 3 1/4, 3 space over 4. Okay, now the bottom three, underside of footing, top of footing, and top of slab. We'll start with the underside of footing just because I know it's going to drop so they won't overlap each other. The underside of the footing is 88 feet 1 3/4. And the top of the footing would be 8 inches above that, which is 88 feet 9 3/4. And then the slab, the top of the slab is going to be 4 inches above that, which is 89 feet 1 3/4. And what we've assumed for our foundation on this project is an ICF wall. And if we use 7 courses of 16-inch ICF, that gives us a 9-foot 4 wall plus the 1.5-inch nailer. And that would be from top of footing to the top of the foundation would be 9 foot 5.5. And once you've got your spot elevations in, then you can do your adjusting just so that everything is readable. Okay, so now we are set with that. Now what I would like to do here is add a spot elevation to control our garage. So these are all of our house spots. We're going to need to control our garage. And what I would like to do is I'd like to have the top of my grade beam in line with the top of the house foundation here. So to do that, I'm going to set a spot elevation for the bottom of the grade beam, which is also known as the top of the piles. So we know that this is a 2-foot grade beam. If I want the top of the grade beam to be down here, all I need to do is take this spot elevation, that's the top of the house foundation, and copy it down 2 feet. Now that spot elevation, we'll just bend it here so we can read it. That spot elevation is known as the top of piles, top of the piles. Okay, so top of the pile is 2 feet below grade. What that means is when we take this stacked wall, and if I select all instances in the project of stacked walls, and I change it, instead of the base constraint being the top of the main floor, which it was, we're going to bring the base constraint to the top of the pile, which makes sense. From the construction point of view, the piles are poured first, the grade beam sits on top of the piles. There we are. We've got a 2-foot grade beam, and then our garage wall right now is the same height as the house wall. We may, it depends on the construction of the house, have a different spot elevation for the top of the garage walls. But I'm going to leave that for now. We'll see what develops in this plan. So eventually there will be a floor assembly in here, and then the house foundation will go here. So grade will be in here somewhere, cutting across here. So if you look at this in 3D, there you can see that our garage is lower down than the house. We've left room for the floor assembly of the house, plus our house foundation will be yet to be drawn.